Okay, so today what we're going to look at, we're looking into what they call flow problems. So we started to look at, in the last chapter, weighted graphs. So that means we had edges with numbers on them. Now we're going to have directions with those edges. So what it means is that it's only the edge, like the flow of whatever's happening, you can only go one way, or the way of the arrow. So a directed graph is where the direction is indicated for every edge. So they will show you, and it's often, they abbreviate it. They may say this is a digraph, meaning directed graph, okay? So you can see they've done a little example there. So they're showing the edge can only move that way. So when we have movement through an edge, we call it flow. Okay, so it might not always be, sometimes they use like water pipes and things like that, but it doesn't matter what it is, it's the flow, it could be the flow of production. So they call flow, so flow means the movement of the arrow. So what we say though with the flow is that we go from the source, so you might want to say the source is the starting point. Starting point, and you end up at the sink, which is what we call the end point. So so the source is the starting point, and they call the sink the end point. So what they'll say is they want you to flow through this network, and they want you to start here, and they want you to end up at the end. So start at the source and end up at the sink. Okay, so what we call the weights on those edges is so every edge has a certain amount that can flow through it, so a number. And so what that's called is its capacity. It puts the highest amount it can go through. So if you have a look, here's an example. So they've got some pipes, 2 pipes joined together. So you can see at the start here, we've got a little pipe that can take 25 litres per minute, and it moves into a big pipe of 58 litres per minute. And then they've got another example of the other way round. So what it shows you, and what we're going to look at, is even though we have that bigger pipe, if you look at it, say that this second example, even though 58s can come into that big pipe, only 25 litres can continue on. And so that's what we're going to start looking at. We have restrictions because edges won't let us take all the flow through. So therefore, sometimes what we'll look at maximum flow. What's the biggest amount that possible can get through this network, because we're going to have restrictions with the capacity, so the numbers on the edges. So as we said there, the source is the origin of the stuff, so the start, and the sink is the end. Okay, so let's have a look at this little example, and so to sort of help you explain it. So we've got the source here, so we can say here's our starting, and that will be our starting vertex, okay? So here's the source there. And in it comes, and we've got, they said this was a sewage system in a neighbourhood. So out of the sewage pipes, it was going, and it's going to end up coming out the sink, wherever that is. Okay, so sewage will pour out of pipe A and down pipe B at the same time. So the arrows represent flow, and sewage can only move in that direction. So you can see the arrows are pointing, the direction that the flow can go. So there's no flow backwards, and we probably wouldn't want that. So the weights represent how many litres of sewage that can flow through the pipe at any time. So if you want to highlight that's a way of saying capacity, yeah? So they use the word capacity. So if you look at pipe A, it has a capacity of 11 I don't know if they were talking about litres, 11 litres, yep. And pipe B has a capacity of 13 litres. Okay, so what we'd see if we were going through this pipe, let's just follow what the sewage would do if we go through A. So you can see you'd go through pipe A, pipe C, pipe G, and then it would come out to the sink. But what's going to happen is we can see pipe G, we're going to have 3 litre, like if you see, we've got 11 litres come out. Okay, so 11 litres is coming out, maximum, like we're going to say the most is going to come out, and then it's going to go, it's fine to go along 12 because it fits through there, but when you see here, it gets to this point and 3 litres are going to be stopped, isn't it? Because that next pipe, or it'll burst. Because if we don't stop 3 litres, the pipe will burst and then we will, we'll have flow. So what we see there, so because this pipe is limited, the flow is limited, that's what we're going to say is the smallest amount of, or the maximum amount of flow that can go through that section is going to be 8, because otherwise we would pop. So the flow is limited by the smallest pipe. So only 8 litres can get through on that spot, on that path. Yeah? So we can only say 8 can get through. So sometimes we say, all right, we had 8 out of 8 come through here. We had 8 out of 10 possibilities come through here. We had 8 out of 12 come through here, and we've used 8 out of the 11 coming through there. All right, so there's, we've seen that's the flow. All right, so then if we look at the other pipe, say let's have a look at pipe B. So B, we can see it shoots out 13. Okay, and now if we went to pipe E, so if you look at pipe E, it's going into G, and we've already maxed out G, so no more is coming through. So we're just going to put a cross through there because we're not going to get any more. So what we say, any pipe leading into your maximum one, so see that G, we're not going to get any more flow from them because it's already hit the max. No more can go through than 8, okay? And it's going to be the same with, so we'll just leave that. So then there's E. So then this 13 flow from B is going to keep going through, but it hits here, it hits this pipe, and now we've only got 10. So 10 is coming through here. So we can put 10 through there. Now, and then we've got 10 come through along there. So if you look at it, the most, so we could have 10 come through here. So really the most flow getting through is going to be that 10 and that 8. So the most flow that gets through, so that's what we say is the maximum flow. So the maximum flow coming through here is going to be 18 litres. Okay, so we had a look. Oh, wait a minute. So actually we can say, what we can say is, we can say that 2 comes through here. It doesn't matter. We could say 2 came through here and then it means only 8 came through there. So 2 could go in there and 2 could be added. It's still going to end up being 18 as the max flow. All right, so that doesn't matter there. But this is what we're going to look at a bit more carefully with our steps. But there's what happens. So the maximum flow is what can flow through at any one time without anything bursting. So the maximum flow for this is 18 litres. So let's just go over. So maximum flow. If the pipes of different capacities are connected one after the other, the maximum flow through the pipes is equal to the minimum capacity. So it's sort of weird. The minimum capacity actually is the maximum flow that can go through because we're restricted. So here's another example. So let's go through. So here's another way. So at the moment, we're sort of just looking at by sort of inspection, but let's give it a go. So what you can do, okay, so what we could do is let's investigate this. So if I went through here, 10, I'm going to go this way, 9, 7, 11. Well, you can see a 7 is my smallest there. So I can get 7 through there. So at the moment, I'm going to say I've only used 7 out of that. Now, 7's full. That 7 pipe is full. So I'm not going to take any more from that 9 pipe because that's feeding into that, and that's just chockers. So then if you have a look, if I go along, so if you have at this pipe at the start where I had 10, so I'm coming along here again. Now I've still got 3 extra because only 7 got used of it, so I've used 7. So what I'm doing is I'm bringing this 3 down here, the 3 that's left, I'm bringing the 3 and I'll add it into there. So that's okay in that last end pipe because I'm only up to 10 and that one can take 11. So there I've used 3 out of that. Now if we keep going, so we've gone... we've used 3 down there. Now, we've got no more, because we've used 10 up now, because I've used plus 3 out of here. I'm going to get rid of that. That's not going to give me any extra. I used the 5 pipe. All right, and so then let me go along the 12 again. So if I go along 12, maybe I'll go this way. Oh, sorry, try the different colour for you. So 12, and then I'm going to go... if I go 10, 8, and 10, I'm just going along. We'll go along. Actually, I'll just keep going in order. So I'll go along here. I'll go 12. I'll try to use it all. So I'm going to go 8 and 4 and down like that. Now, if I go along there, the 12, 8, the 4 is the smallest, but this pipe down here, this 4 is leading into this 11 pipe, and I've only got 1 more left. So I'm adding 1, so it means I've taken 1 out of that 4, 1 out of that 8, and at the moment I've taken 1 out of that 12. Okay, so because that's leading, this 4 pipe is leading into that 11. 11's now full, so I'm just going to say that's now full. So I'm going to cross off this. We can't lead into that one anymore, and we don't want to put into that either because that's full. So then, and same with this 3 here, it's going into the 11 pipe, so it would burst it, and so would that 7, so I'm getting rid of that. And then the last one little way I could go is I could go through here. Okay, now I've got 11 left at the start up here because I've used 1 of them. So I go 10, but this 8 here is going to restrict me. So that means I'm only going to put 8 come through out of here. So we're going to use the 8 out of the 8, 8 out of 10, and then we're going to add 8. So really in that first pipe from the source, the 12, we only used 9 litres of it, came out. And then anyway, we get down to the end. So this is going to show me what maximum flow was. I used all the 11, 7 plus 3 plus 1, and I used all of the 8 came into the sink. So maximum flow is 19. So 19 is maximum flow here. Okay, so another way of checking to find maximum flow is to use these cuts. So cuts, if you want to just write a little note, is a method of finding maximum flow. Okay, so what you see, so sometimes it's difficult to determine maximum flow by inspection. So what I sort of was doing there, I began with inspection, but I was actually doing an algorithm method with you, which I think I can't, once I've done that, it's very hard to go back to inspection. So I think just use that way anyway. So, but this cutway is also, it can be handy, sometimes a little bit harder to see. So it's difficult to determine maximum flow by inspection for a directed network that involves many vertices and edges. We can simplify the search for maximum flow by searching for cuts within the digraph. So remember, the digraph just means we've got a network with directions, which we have, and it's helpful to think of the cuts as imaginary breaks. So that's important, where the block of it's like you're cutting the network. And what you have to make sure is that when you do this dotted line is the cut, you have to make sure that the cut is separating the source. The cut separates the source from the sink. So so you want to see it break off. So what they do, so if you have a look here, we've got a cut here. So this cut here is cutting through the thing. So what we like to do is often you like to highlight, I'm just going to write that this was the source side, and they're calling this the sink side. So if you highlight the sink side, and so it means if you can separate, if you cut it there and you moved it apart, you have to make sure that the sink moves away from the source, which it does. So then what you've got to do is, when you're looking at the cuts, you go through, if the vertex is on the source side and that edge is going through the cut, so can you see this one is going through the cut? So when that happens, when you go the edge going from the source into the sink, that means we count that. So we count that when we're adding up our flow for this cut. Now see this 400, it is also an edge going from the source side into the sink, and same with this bottom one, this 600. So this one has a cut capacity. So they'll call it the cut capacity of 1,000 plus 400 plus 600. So remember, it has to be flowing from source to sink, because sometimes we'll have backward flows and you don't count them. So this one's the cut of this would be 2,000. So then what happens is, so what they're saying down here is this is a valid cut, this one, because if I moved that away, if I pulled it apart where the cut was, you would separate the source from the sink. But see how this bottom one, if you do that, if you pulled the highlighted part from the non-highlighted, you still got the source and sink together, so that doesn't work. All right, so what this cut capacity is, you can keep cutting the network all these different ways, and your lowest cut is your maximum flow. So let's have a look. So a cut to a flow diagram is a line that passes through the edges. It separates the source from the sink, and the capacity of the cut is found by adding up the edges. So I just wrote that down, what I just said before. It's the edge coming from a vertex on the source side going into the highlighted side through the cut. So what I'm going to do here is I'm going to do, say, this first cut A. So I just like to, because you're going to get a few cuts, don't highlight the whole area. I just highlight the sink side of the cut, and then I go through and I have a look. So this vertex here is on the source and it's going through the cut, so I'll have to add that 12. So even though the 12's on the other side, but it's actually coming through. And then if I look at this line here is going through, so that's 7, 5 is also going through, and so is this 9. Okay, so I'm just going to write here, cut A equaled 12 plus 7 plus 5 plus 9. What's that? 33. And that's what they said down here. That's good. All right, let's do the next one. Cut B. So I'm just doing it with a different highlighter. So I'm going on the sink side, highlighting it. And then I look at all the lines crossing that dotted line, crossing the cut. So I'll start down here. So this 12 is also cutting through that B one. Now, see the 8, I'm not counting the 8 because the 8's vertex, this one here, I'm talking about this one here, it's on the sink side. So it doesn't count, does it? I want to go from any line going from a vertex on the source to the sink. So the same with that 6. Now, this 4 though, it is, isn't it? So this 4 is cutting through. So is this 5. So I'm just drawing another circle. And so is this 7. Okay, so if I do cut B equals 12 plus 4 plus 5 plus 7. So I got, what's that, 16, 21, 28. So a cut of 28. Can you see that? So be careful with the backflow. That's why you just be really careful. Now I'm going to do the last one, C. So I'm highlighting on the sink side. And then I'm looking. Now 8 is cutting through. Now this 7 is on the wrong side. So I'm not counting that one. But this 11 is. So cut B. C, sorry, beg your pardon, is, what did I say? 8 plus 11, which is 19. So the maximum flow through this one is 19 because that's the minimum cut. So capacity of cut. The cut capacity is the sum of all the capacities of the edges that passes through, taking into account the direction of the flow. So remember what we're saying there is that you have to go from, it has to be going from the source to the sink for you to count it, yeah? All right, which is what that little note up here, I tried to sort of explain that a little bit better. Okay, so, sorry, I've already highlighted this one, but this one in the graph, the capacity of the cut is shown. So I've highlighted the edge and I'm looking at the vertex, so this vertex, and it's cuts through the cut. So that one is going from, this is the source, and they're saying, well, they don't really say, but just pretend that side's the sink, the other side's the sink. So we're going, 6 would count 4. Now, we're not going to count that 5 because it's on the wrong side. And this one coming through here is on the right side. So that was 9 and 2. So you can see I've added it up. 6 plus 4 plus 9 plus 2 equaled 21. So that was an example of a question. You might just get a cut question like that. Okay, so with this one, in the graph, which one of the cuts has the capacity of 27? So we just went through them. So if I start at cut 1, I think I've done it in green. I'm just double check myself. So I've highlighted through here. And now I'm going to go through. So that 4 counts. Where else is it cutting? This 7 counts, and this 4 counts. I think I've put this one wrong. Just gonna rub that out. So we got 4. Why don't I count that 3? Because it's coming from, oh, I do count that 3, don't I? Yep, it's coming from the source into the sink, so that was actually right. This 7 counts, this 4 counts, and this 6 counts. So we had 4 plus 3 plus 7 plus 6 plus 4. So that ended up being, was that 24? Okay, if you look at the next one, so I've done cut 2 in purple. So I'm highlighting on the sink side, and I'm going to circle the ones that are cutting through. So 8 comes from the sink, the start to the sink. 2's backwards, so I'm not going to count that one. The 3 is backwards. This 8 is going from the start to the sink, and so is this 6. So I'm just drawing another little circle. So am I missing one? 8 plus 6. No, that's it. Then if we look at the red one, which I think blue next. Blue is cut 3. So I'm highlighting on the side of... So you could, with you guys, if you've got your highlighters, you could highlight and just put, like, so say for this one, I'm going to highlight the blue, the cuts. So 8 was going in, 7 is going in, and I've got 4 going in, and I've got 6 going in. Wait a minute, is that right? 6, 4, 7, not the 2 and the 8. I think I've done that one wrong.
Yes.
Yeah. So, all right, so then we've got that one. We had 8 plus 7 plus 4 plus 6. That was 25. If I keep going and I do the red one, which I said was cut 4, this is my answer. So once I get it, you would move on in an exam, but I did the last cut just in yellow to show you if you want. So if we look through here, this 8 is coming through the red cut. This 7 is coming through the red cut. See how this 6 starts here? So it goes into the highlighted, that's counted. And this 6 here as well. So that counts, and that's the one we got 27, and that's how it's cut. So the minimum cut capacity possible for a graph equals the maximum flow through a graph. So what you can do, so the maximum flow from A to G is, so here was this is what they're saying is the source, and I think G's gone missing. This was G, and this was the sink. So what you can do is you can just try and create cuts and see which one it is. So what you often do is do it at the start. So if you look at the start, that one's pretty easy. That cut, it'd be 10 plus 4 plus 5. So that one's a cut of 19. Okay, if you do this end, we've got a cut of 16. Now, what you have a look, if you have a look in this example, they don't have 16 and they don't have 19. They've got 14's the lower, they've got 10 and they've got 14. So what you want to do is you can keep trying to make other cuts. So what I could do is I could cut through, say like this. And if I look through that one would be the 9 plus the 3 plus the 4. So that one would be a cut of 16. So I could cut through that way, or I could cut through this way, like this. And that one would be 6, 5, 3, and 4. So that's already... what did that be? What did I say? 6 and 5 is 11, plus 3 is 14. So this one would be 18. So it's already pretty big. But what I mean, if I cut through, here like that, that would be 6, 4, and 4. So that would be 14. I can't get any other smaller cut, so this one is the minimum cut of 14. So there's a way you could do the cut, or you could do the other method that I did before, when I was flowing through. Just to be careful, just so you understand, maximum flow is the minimum cut. You need to find the minimum cut, because remember, you're only... you're restricted by, remember, the pipes will burst, yeah? So minimum cut is actually maximum flow. Okay, and then let's just do question 7. It says, when the maximum flow is occurring, the flow from D to E is. So what they're saying there is, how before we wanted to look at whether... are you using all of that D? So a lot of the answer is 4 in this case, because we are using the maximum capacity of that pipe. But for some reason, this might be where you could get trapped up. So if you use the other method, so let me just go through that with you. So if we did the other method where I highlighted through, so say I go 10, 10, 9. So 6 was the maximum I could use. So 6 here, I've used 6 there, and I've used 6. Now, because 10 leads into that 6, I'm done. And okay, so I can't put any more. If I look here, 5 is coming from here, so 4. So I used 4. Now I've got 3 that I could add in here. So I'm going to say I use 3 out of the 5 and 3 out of the 4 coming through there. So now this 9 pipe's full. So I don't need to get rid of that. Sorry, I can still use a little bit. So that 4, I still can use one more, and I might use the 1. It'll gonna go through here. So I've got +1 to add. Now that guy's full, and I used 1 out of 3, and 1 out of the 7 has come into there. Okay, so then I look at my last option along here where I had 5 come down and then 4. So really I can only use 4 here, and then I've got 4 can still go through that one. So you can see maximum flow, I did use 4. So when it said maximum flow through D and E was floor. But I just want you to write, that's an easy question. Well, you know, most kids are going to guess that anyway. But what if I said what was maximum flow through, if I said F and E, F to E. So really we only used 1, didn't we?
It could be 3, it could be 1.
Yeah, so 1 or 3. So you just got to be careful. You might not have, or say, actually probably not the best. That was probably not, because you're right. It could have different options. But if we said from E to G, the maximum flow through that is only 5. Yeah? Yeah, we only used 5 through there. Alright, so with this one, I've just put another example so you've got your notes. I'm not going to go through it, but, you know, say for example, I just will show you the minimum cut in the end. So they went through all the cuts, and the lowest was cut 5. And if you look at cut 5, it was there. So cut 5 went, I'll draw it in that. Cut 5 went like this. So you can see this 3 was counted, this 3 was counted, and this 1 was counted. So 3, 6, 3 plus 3 plus 1, that's how they got 7. So there was a cut, or you could have done the flow.